Hey everyone, and welcome. Today, we are diving into a piece of technology that could completely rewrite how we treat disease. What if we could make medicine smarter, more targeted, and way more precise than anything we've ever had before?
Just think about that for a second. What if a really powerful drug could navigate through your entire body, completely ignore every single healthy cell, and then wait, only activating at the exact moment a doctor gives the command right at the site of the problem? Well, that's the incredible idea we're exploring today.
One of the biggest hurdles in medicine isn't always about creating a powerful drug. It's about getting that drug to the right place, and only the right place. Most treatments, something like chemotherapy for example, have a really hard time telling the difference between a cancer cell and a healthy one. And that, of course, is what leads to those awful side effects.
So think of it this way. The way we do it now is kind of like a shotgun blast. You fire it in the general direction of the target, but you cause a ton of collateral damage to all the healthy tissue around it, and that's where the side effects come from. The goal, the dream really, is a precision strike. It's like a guided missile that hits only the diseased cells, leaving everything else totally untouched.
This whole problem really boils down to two main failings. First, you've got poor spatial specificity. That just means the drug doesn't know exactly where to go, so it ends up hitting the wrong targets. And second, there's a lack of temporal control. The drug pretty much starts working the second it's in your body, which isn't always the best or most effective moment.
So, how do we fix this? Well, researchers have developed this absolutely revolutionary new platform called OnTarget. And the best way to think about it is like a programmable microscopic smart safe for medicine.
Okay, so at its core, OnTarget is this teeny tiny box that carries medicine inside. It's actually built using something called DNA origami, which is as cool as it sounds. Scientists literally fold strands of DNA into a precise 3D shape. But here's the genius part. This box is locked, and it's designed to stay that way until it gets two very specific, separate signals, kind of like a high-tech safe that needs two different keys to open.
And this is the fundamental principle here. In engineering, they'd call this an AND gate. It's not enough to have key A, and it's not enough to have key B. You absolutely have to have key A and key B at the very same time for that box to open. This dual key requirement is the real secret to its incredible precision.
All right, so let's break down that first key. This one is all about what we call spatial control, making absolutely sure that this little package gets delivered to the exact right address inside the body.
So how does this microscopic safe know it's at the right house? Well, its surface is covered in these tiny molecular sensors. You can think of them as keys. These keys are programmed to hunt for very specific proteins, or locks, that are only on the surface of a target cell. And to be extra sure it's got the right address, it needs to find a cell that has two different locks, like a house that has both a red door and a blue mailbox. It's only when both of those keys find their specific locks on the very same cell that the first latch pops open. This makes the chance of it activating on the wrong cell basically zero.
So, there you have it. That's what gives the system perfect spatial control. The medicine is now armed and ready to go, but only because the safe is confirmed it's in exactly the right neighborhood, right up against the diseased cells. So, condition 1 is met. Okay, so the safe is in position, but it's still locked. It's waiting. Now it needs that second key, a direct command from a doctor to release its payload at the perfect moment.
But that brings up a pretty wild question, right? How in the world does a doctor from outside your body turn a key on something thousands of times smaller than a grain of sand without any kind of surgery?
The answer is just so simple and elegant. You use a focused magnetic field.
Here's how that works. Attached to that second latch, there's a tiny little particle of iron oxide. A doctor then uses a special device to create a completely harmless, alternating magnetic field that's focused only on the target area, let's say a tumor. This field makes just that tiny iron particle heat up, creating a little localized hotspot. And that pinpoint of heat is just enough to melt the final DNA latch, and pop. The box springs open, releasing the medicine exactly where it needs to be.
And that is what provides the temporal control. The medicine isn't just released at the right place, but at the exact moment that doctor decides is the best possible time. It really puts the clinician right in the driver's seat of the therapy.
Okay, so we've got a system that gives us control over delivery in both space and time. So what does that really mean for patients? What kind of amazing things can this smart safe actually do?
Well, the potential uses are just staggering. For cancer, imagine delivering toxic chemo drugs directly inside a tumor, leaving all the healthy tissue alone.
For regenerative medicine, you could release growth factors precisely at an injury site to supercharge the healing process. In gene therapy, you could use this to sneak CRISPR gene editing tools past the body's defenses to fix a broken gene. Or for autoimmune diseases, you could release calming agents only at the specific spot where there's an inflammatory flare-up. It's not just a single drug, it's a true platform.
And get this, for missions that are extremely sensitive, maybe something like gene therapy in the brain, the whole system is modular. You can actually add a third lock, a triple fail-safe, that only opens when it's hit with a specific frequency of light. That just adds another incredible layer of control and safety.
When you step back and look at the big picture, this really represents a huge shift in how we think about medicine. We're moving away from the idea of medicine as just a passive chemical that we put in the body and kind of hope for the best. With a platform like OnTarget, medicine becomes an active, programmable device that carries out a specific command based on information it finds in the body. It's a total game changer.
And all of this leaves us with one final, really exciting question. Now that we have the power to program medicine with this incredible level of precision, to control it in both space and in time, what's the very first problem we should tell it to go out and solve? The possibilities are just about endless.